Welcome to Pre-Algebra with Miss Betsy. Today we are going to be discussing how we estimate sums and differences by using the idea of rounding. I'm using as my text Pre-Algebra for Christian Schools. It's published by Bob Jones University Press. If you wish to track along with me, you must be using the first edition. The new edition, the second edition, is not compatible with this, but you can still learn about rounding and estimating, even if you don't have the same text that I do. Let's go ahead and pray and we'll get started. Father, thank you for your goodness to us and for giving us the ability to think and to reason and to learn how to manipulate numbers so that we can understand much more about the world that you've created around us. Father, I pray that you would help us to be attentive to those things that you would have us to learn today. In Jesus' name, amen. Okay, if you're using the same text that I am, we are on page 25. It's section 1.7, and it's entitled Estimating Sums and Differences. This should be a very straightforward, quick section for you. I would expect that the majority of you studying rounding numbers for a very, very long time. There are two basic rules for estimating. Let's take this number here. If we have 2,765. First, you have to know what your places are. You have to know that you have units, tens, hundreds, thousands, 10,000s, 100,000s, millions. You need to know what place value is. And this lesson today is not a point for a review of that. But we have this number here, which is 2,765. And let's say that we have a question where we're being asked to round to the nearest 100. And I'm going to show you that second. I'm going to say round to the nearest 1,000. So you have to know, okay, which one of these places is 1,000? The 2 is in the thousands place. So we want to round this whole number to the nearest 1,000. If this is the place to which we are rounding, we're going to round to the 1,000. What do you do to figure out how to round it? You're going to look at the digit immediately to the right of it. If this digit is 5 or above, 5, 6, 7, 8, 9, the digit that's being rounded is going to increase by 1. This is 5 or above. Our 2 becomes a 3. And the remaining digits are zeros. So 2,765 rounded to the nearest 1,000 becomes 3,000. Do you understand what it is that we're talking about when we're rounding a number? We want to come up with an estimate of, sort of a close number that makes our arithmetic much easier. And you see examples of rounding all the time in the newspaper. I'll say, there were 50,000 people at the football game in your local stadium. Well, did they get out there and count every single one of those people? No, they didn't. They have ways of saying, okay, there are about 50,000 people. If we have 2,765, they're saying about how many thousand do we have? Another way, let's think about this right here. If we have a number line, over here is 0. But let's say I have 2,000 here, and I have 3,000 on the right-hand side. What they're doing is they're asking you, when they ask you to round to the nearest 1,000, the nearest 100, the nearest whatever it is, they're saying, is this number closer to the 2,000 or closer to 3,000? That's really all they're asking you. So halfway between here, would be 2,000 500. Halfway in between both of these, 2,250, 2,750. So about where would we locate this number on the number line? Well, we would locate this right approximately there. Clearly from this picture here, 2,765 is closer to 3,000 than it is to 2,000. And that's why the rule for rounding says if the digit immediately after the place that you're rounding to is a 5 or above, we're going to say that it's closer to this end. You know, the point right in the middle, you have to decide arbitrarily if it's going to be larger or smaller. So we say if it's a 5 or above, we're going to round up, meaning that it's closest toward, on the number line, towards that next larger 1,000. So, we've just seen the 2,765 rounded to the nearest 1,000 is 3,000 because it's much closer to 3,000. Now, let's change the problem and say, what if we had 2,300? What did I do with my eraser? Don't know where my eraser is right now. 2,365 rounded to the nearest 1,000. We look at this digit. It is not a 5, 6, 7, 8, or 9 because our last rule said if it's a 5 or greater, we're going to increase this digit by 1. We're going to round up. If it's 4 or below, does that mean that this 2 is going to become 1 so that it rounds to 1,000? Well, doesn't it make sense? Because I said, well, if this second digit is at 5, 6, 7, 8, or 9, I'm going to make that 2 go up. Well, if it's less, shouldn't the 2 go down to 1,000? No. Look at our picture here of our number line. Where is 2,365 going to be approximately on this number line? Maybe someplace around here. Is that anywhere close to 1,000? No. This is a common mistake that you make when you're first beginning to round numbers. It's not going to round to 1,000. Rather, it's going to round to 2,000. So you see there the two basic rules that we want to pay attention to when we're rounding, and I see another eraser over here that I can use. It would get old very, very quickly erasing the entire board with my fingers. If the digit is 5, 6, 7, 8, or 9, increase the digit you are rounding by 1. Okay, this is not, I'm not really thrilled with the language that I've used here because it's the digit in the place value to which you're rounding that you're increasing by 1. I think you can understand from what I've illustrated to you exactly what I'm talking about. However, if it's 4, 3, 2, 1, or 0, the digit remains the same. When we first began this class, way back at it may have been section 1.1, where we used numbers and we graphed numbers on the number line, and we talked about how having a number line or a picture of something can really help us understand things a lot of the time in math. That's why I use that number line here to help you get a good idea of what rounding is. So let's do a quick review here. Some quick samples. 1,235. If we want to round this digit to this number to the nearest hundred, what are we going to do? We're going to look at the digit in the place that we're rounding to. We want to round to the hundreds. You have to look to the digit next to it. It's a 3. What are we going to do? We're going to keep the digit in the place that we're rounding to the same. So 1,235 is approximately equal to 1,200. Do you see this is a little bit different than rounding for the thousand? You have your digit in the place value to which you're rounding. All of the other digits become zeros. What if we had 287,423 and they ask us to round to the nearest thousand here? We're going to round to the nearest thousand here. Look at the digit to the right of it. The digit is a 4. Which one of these are we going to use? We're going to use a second rule. The digit that you are rounding remains the same. So that's approximately equal to 287,000. This little squiggly thing here, that means it's approximately equal to. Now, what can we do to help make sure that we understand where we're putting those zeros? When you have a problem and it says round to the nearest 100, round to the nearest 1,000, round to the nearest million, when you read the word, you're going to end with the place value to which you are rounding. We said round 287,423 to the nearest thousand. When we rounded that, we have 287,000. We were rounding this 1,235 to the nearest thousand. When it's rounded, we have 1,000. Okay, I misspoke. We didn't round this to the nearest thousand. We rounded this to the nearest hundred. 1,235 is approximately equal to 1,200, or 1,200. You see the last word out of your mouth when you read your number after you have rounded is going to be the place value that you round the number to. Let's look at this great big long gigantic number, but not with a green pen. I have 1, 2, 3, 4, 5, 6, 7, 8, 9. 123,456,789. First, let's round to the nearest 10 million. See, that one's going to be a little bit too big to follow the example that I just gave you, but I still want to show you. And look, this is the hundred thousands, millions, 10 millions, units, tens, hundreds, thousands, 10,000s, 100,000s, millions, 10 millions, 100 millions. We're going to round to this place. Look at the digit to the right of it. It's below 0, so you have 1, 2, the 2 stays the same. 120 million, period. Everything else rolls over to a 0. It's in the 10 million. In your tens, you have 10, 20, 30, 40, 50, 120 million. If we want to round to this 1,000 here, I'm really keying in on the thousands, aren't I? We're going to round to this. Look at the digit to the right, it's increased by 1. It's a 7, so this 6 is going to increase. We're going to have 1, 2, 3, 4, 5, 7. If we're going to round this 123,456,789 to the nearest 1,000, it will say 123,457,000. Everything else becomes 0. Okay, I think you'll be all right with these. If you get stuck, send me a text. Now, they have another technique that they talk about in your book. It's called front-end estimating. Let me see, before I go to that, let me back up. We have sort of beat to death the idea of estimating numbers. Now it says you can use rounded numbers to find an approximate answer to a sum or difference. Study the procedure for estimating sums and differences given below. First, round the number to the same place value. Second, compute the estimate using those rounded values. Well, that makes a whole lot of sense, doesn't it? We have an example of, this is example number 2, page 26, and it says, estimate the value of the variable by rounding to the nearest 1,000. N is equal to 17,436 plus 2,517. N is equal to 17,436 plus 2,519. We don't want to do this multiplication in our head. They're asking us to figure out, okay, about what is going to be your solution here. And they want you to round this to the nearest 1,000. Okay? The first number rounded to the nearest 1,000 is 17,000, isn't it? We look at the 7, it's in the thousands place. The digit to the right of it is 4. So this does not increase. It's closer. This number here is closer to 17,000 than it is to 18,000. Now, let's look at 2,519. We look at that digit to the right of the 2. It's a 5. Our rule tells us that it's going to round up to the next digit of 3,000. What that means, picture our number line, 2,000 on the left, 3,000 on the right. This number is closer to 3,000 than it is to 2,000. Now we have a very easy estimation of what this sum is when we round. We get about 20,000. And that's the same principle, the same idea that we used when we used estimation to check our word problem in the last video. Okay, now, front-end estimation is what they're calling. Technique that they're talking about here, we just rounded the numbers, but we had differing place values here. This went out as far as the 10,000s. This went to thousands only. Excuse me. When you use front-end estimation, the numbers have to each have the same number of digits. So this is front-end estimation. Okay, the numbers have the same digits. Have the same number of digits. So if one number is thousands, the second number has to be thousands. This is key. They have to have the same number of digits. And what process are you going to use? Your book tells you on page 26, add or subtract the first digits to get an initial estimate. Then adjust that initial estimate according to the compatible numbers in the remaining digits. And you read that and your brain goes tilt. That is just so math language, and I'm lost and I'm going to give up. Let me show you what they're talking about. Our example 3 says, estimate the value of the variable using front-end estimation. 373 plus 224 is equal to y. 373 plus 224 is equal to y. The first thing that it tells you to do is add or subtract the first digits. Well, first we notice that these are both hundreds. If we add or subtract the first digits, that's going to be 500. We're going to just take the 3 is in the hundreds place, plus the 2 is in the hundreds place over here. So 300 plus 200 is 500. Now we look at the rest of the problem. 73 plus 24, that's about 100, isn't it? And let's see what they do here. That's about 100. So using front-end estimation, with this problem, we see that we have approximately 600. Now, what I would tend to do, in all honesty, is say that 373 is about 400. 224 is about 200. And I come up with that same estimation, but sometimes using this front-end estimation here will give you a little bit better estimate when the numbers are larger that you're using. All right, let's go ahead and look at this skill check, go through some of these examples here. Skill check says round to the indicated place. If we want to round 78 to the nearest 10, well, that's an easy one. 78 to the nearest 10 is 80. We figured that out because 8 is 5 or greater. We want to round 628 to the nearest 100. The digit 6 is in the hundreds place. 2 tells us that 628 is closer to 600 than it is to 700. 78 is closer to 80, so the 7 increased by 1 to 8. Problem number 3 says 24,763. And they want to round this to the nearest 1,000. The 4 is in the thousands place. The digit to the right of it is 7. So this is going to increase to 25,000. Number 4, 305,219. And they want us to round this one to the nearest 100,000. The 3 is in the 100,000 place. The digits to its right is 0. This number is clearly much closer to 300,000 than it is to anything else. All right? Now, questions 5 and 6 want us to estimate the value of the variable by rounding to the nearest 10. 64 plus 37 is equal to B. 64 rounded to the nearest 10 is 60. 37 rounded to the nearest 10 is 40. You have that B is approximately equal to 100. Now we have one where we are subtracting 183 minus 59. This is going to work the same way. We're going to estimate the value of each of these. Now let's see how much you want to do that. You're going to round to the largest digit. 200 minus 60 is the approximate value of P. So P is approximately equal to 140. Let's see. Estimate the value of the variable by rounding to the nearest 1,000. 461 plus 725 is equal to X. We want to round to the, this says estimate the value of the variable by rounding to the nearest 100. 461, the digit to the right is 6, meaning that 461 is closer on the number line to 500. A 725, the digit to the right is a 2, tells us that 725 is closer on the number line to 700 than it is to 800. The value of X is approximately 1,200. So enjoy these. I think you'll find these a nice break from the word problems that maybe were a little bit more challenging for you. Once again, if you have difficulties, send me a text, ask me questions on Friday. I'll see you next time.